Okay, in this video, we are going to go over this problem here. Find the integral of 1 over the square root of 4x squared plus 9 dx using trig substitution. So it's nice because the question tells us, make sure you use trig substitution. If it hadn't told us that, one of the very big indicators that you're going to use trig substitution is we have something that looks like a Pythagorean theorem there. So the first thing that we need to do is look over at our rules and figure out, are we going to use 1, 2, or 3? And then we might want to rewrite this so that it shows the rule a little bit more clearly. So for this one, we're going to use rule 2 because of the plus sign. 4x squared plus 9, and then we've got a plus sign here. And so if we were to write this a little bit more clearly, just so that we could really see what a and u were, we could say the integral of 1 over the square root of 3 squared plus 2x squared dx. Now, I haven't done anything to alter the equation because the plus sign, it doesn't matter which order I add. And then that squared, all I did was I broke it up, and 2x squared is the same thing as 4x squared. That allows me to very clearly see that my a is 3 and my u is 2x. That then allows me to start applying this rule, to start applying these conditions and substitutions. I like to always start by drawing the triangle. As you get really good at these, you might not need to draw the triangle. For me, it really helps me out. So I draw the triangle, and because of the plus sign, I know that my hypotenuse will be my radical. So 4x squared plus 9. Theta is always coming out of the origin like that. My horizontal leg is going to be A, and my vertical leg is going to be U. And I know that from the rule. From looking at this triangle here, that's what the rule tells me. Now, the rule also tells me that I can substitute my U, and my U is 2x, with A tangent of theta, which A is 3, and then we have tangent of theta. Now, this isn't just a game of memorizing. It really isn't. You can derive all of that from this triangle. And so let's just do a little side note here, just so that you can see where all these things are coming from. And in our little side note, this is theta. Well, tangent of theta is going to be 2x over 3. So tangent of theta is opposite over adjacent, which is going to be 2x over 3. Now, if I were to solve for 2x, I would multiply that 3 up. And there we have it. So this really isn't just a game of memorizing. You can derive every single one of these by just working through the math of the right triangle. Now, the cool thing about this is it has given me something to replace my 2x with. So my 2x can be replaced with 3 tangent of theta. That's nice. The other thing that I'm going to need to replace is I'm going to need to replace this dx. Because if I get my x's in terms of thetas, then I'm going to need to integrate with respect to theta. You don't want to have a different variable than you're integrating with respect to. That doesn't make any sense. And so we have to find a way to get dx. Well, I have an x here. So if I were to solve this for x, I would have x equals 3/2 tangent of theta. And then if I take the derivative of this, I can figure out what dx. So dx equals 3/2. The derivative of tangent of theta is secant squared of theta. And because we took the derivative with respect to theta, we would say d theta. Now I can replace my dx with that. So my new integral is going to be 1 over the square root of 3 squared minus 3 tangent of theta squared, and all of that's in this radicand, times 3/2 secant squared theta d theta. Okay, so that doesn't look any prettier yet, but I can see some things start to come together. The next thing that this rule tells me is it tells me that this whole business here, the a squared, this is supposed to be plus. Sorry, guys, there's a plus there, plus here. This a squared plus u squared is a secant of theta. So you can do the math on this. You can actually square this. You would factor out a 9, and then you would see that you'd have um, 1 plus tangent squared of theta, which is secant squared of theta, and then you would take the square root. But because we have this rule, let's go ahead and just substitute it in. That's what trig substitution is. So we're going to have 1 over a is 3 secant of theta times. So what I did, in case you are like, what the heck, Mrs. Roberts, I took this and I replaced my whole my whole radical. I replaced my radical with this. Okay, so now that's going to be multiplied by d theta, so 3 over 2 secant squared of theta d theta. I see that I have a secant in my numerator and in my denominator, and I see I have a 3 in my numerator and in my denominator. And so when I clean this up and make it a little bit prettier, I'll pull that 1/2 out front, and I'm going to have the integral of secant of theta d theta. Now that integral might be one that you don't have memorized, and that's okay. Let's pull out our review of basic integrals. And we will see secant of u is right here, and in this case our u is theta. And so we can integrate this using this rule, and so we're going to have 1/2 ln the absolute value of secant of theta plus tangent of theta plus c. Okay, now here's our answer. We've integrated it, but the problem is that this is in terms of theta, and our final answer should be in terms of x. Final answer should be in terms of x. And we can get this in terms of x by looking at our triangle. So we're going to go back up to our triangle there, and if we want to find the secant of theta, we'll use our right triangle ratio. So secant is the reciprocal of cosine, and so that means this is going to be hypotenuse over adjacent. And then tangent, our tangent, we already figured that out, is right here. Tangent of theta is 2x over 3. So now I can replace those in here. And so I'm going to get equals 1/2 ln. My secant is the square root of 4x squared plus 9 over 3, plus my tangent is 2x over 3, and then plus c.